In this series of numbers, the next term is twice the previous term. Therefore, an is 2 times an minus 1. In this series, the next term is 1/3 of the previous term. Therefore, an is 1/3 an minus 1. These are geometric progressions, or GP. In a GP, the ratio of two adjacent terms remains constant. The ratio R is called common ratio. An is an minus 1 times R. A is the first term. A2 is AR. A3 is A2 times R, which is AR squared. A4 is A3 times R, which is AR cubed. In general, an is AR to n minus 1. Now let's find out the sum of a GP. S is A plus AR squared plus all the way to AR to n minus 1. Multiply R on both sides. The left side becomes RS. The first term A becomes AR. The second term AR becomes AR squared. The third term AR squared becomes AR cubed. So every term is moved to the right by 1. And the last term becomes AR to n. Subtract these two equations. The left side is 1 minus R times S. After subtraction, all the middle terms, AR squared, AR cubed, all the way to AR to n minus 1, are all cancelled. So it becomes A minus AR to n. Therefore, the sum S is A times 1 minus R to n over 1 minus R. If R's modulus is less than 1, when n approaches infinity, R to n approaches 0. So sum to infinity is A over R minus 1. Let's look at an example. Calculate 32 plus 16 plus 8 plus 4 plus 2 plus 1. This is the sum of a GP. A is 32. R is half. N is 6. Using the formula, we get the sum as 32 times 1 minus half to 6, over 1 minus half. This is 63. If we add 32, 16, 8, 4 and all the way down, this will be a sum to infinity. A is 32. R is half. Using the formula, we get the sum as 32 over 1 minus half, which is 64. The second term of a GP is minus 8 and the fifth term is 64. Find the first term and the sum of the first 7 terms. The second term A2 is AR, and it is minus 8. The fifth term is AR to 4, and it is 64. Divide these two, we get R cubed is minus 8. So R is minus 2. Put it back into the first equation, we get A as 4. Using the formula, the sum of the first 7 terms is 4 times 1 minus 2 to 7 over 1 plus 2. It is 172. John deposits $100 in a bank account at the start of each year and earns 3% compound interest. How much does he have in the account at the start of the 30th year after he makes his annual deposit? Let's look at how the first year deposit changes through these 30 years. At the start of year 1, it's 100. At the start of year 2, it grows 3% and becomes 100 times 1.03. At the start of year 3, it grows 3% more and becomes 100 times 1.03 squared. At the start of year 4, it grows 3% more and becomes 100 times 1.03 cubed. And at the start of year 30, it becomes 100 times 1.03 to 29. This is the $100 deposited at the start of year 1. For the $100 deposited at the start of year 2, it grows to 100 times 1.03 to 28 at the start of year 30. For the $100 deposited at the start of year 3, it grows to 100 times 1.03 to 27 at the start of year 30. So on and so forth. The deposit at the start of year 30 is $100. So the sum is 100 plus 100 times 1.03 plus 100 times 1.03 squared plus all the way to 100 times 1.03 to 29. A is 100. R is 1.03. N is 30. Using the formula, we have the sum as 100 times 1 minus 1.03 to 30 over 1 minus 1.03. It is 4757.54. In this class, we learned: in GP, A is the first term, R is the common ratio. An is An minus 1 times R. An is AR to N minus 1. Sum of the first n terms is A1 minus R to N over 1 minus R. Sum to infinity is A over 1 minus R, when R's modulus is less than 1.